All right, this is 8.6 is factoring ax squared plus bx plus c, where a is not equal to 1. Previous lesson we were factoring x squared plus bx plus c, where that first number in front of x squared was a 1. So steps 1 through 3 are exactly the same as the big X from the previous lesson. We are still looking for two numbers that multiply to equal 3 times 2 here, the first and the last number, and that goes here. So you take 3 times 2, which equals 6, that goes in the top, and they have to add to equal the 5. And then the third step on there was to find those values. So we think of all possible factor pairs of 6, like 1 and 6, 1 times 6, I should say, and then 2 times 3. And we're going to take the factor pairs that actually add to equal 5, so the 2 and the 3 work. So all of that is the same as before. Now, step 4, we're going to add something here. If the coefficient of x squared, or the number in front of x squared, is not a 1, then we have an added step here. We're going to connect this to our rectangular box that we used for multiplying polynomials. This is also known as factoring by grouping in some textbooks. But it says fill in the box. First term in the upper left. So the first term here is 3x squared. We're going to put that in the upper left. Last term in the bottom right, so that last term is 2. So first term, 3x squared, last term 2, bottom right. Both factors finish with one variable each. So what I mean by that is that the 3 and the 2 finish the table in any order you want with one variable attached to each. So it's 3x and 2x. If the variable was different, you'd have a different variable with those, but we are splitting 6 up, actually I'm sorry, splitting 5x up into 3x plus 2x. If you looked at this diagonal right here, you'll see that the 3x and the 2x add up to equal that middle term 5x right here. And the 3x squared is here, and the 2 is here at the end. And so what you see in the box is exactly what we started with, just written in a different way. So I'm going to erase this and I'll put these back in. 3x and 2x back in here. All right, fifth step is pull out the GCF. Here's why it's so important that we can factor out a GCF from two terms. So we're going to factor out the GCF from both columns and rows to get the factored answer. Here's what I mean by that. Looking at this first row right here, the GCF of 3x squared and 3x, well, here's how we did it before. We'd take 3x squared and 3x. We'd do a little factor tree with it. And 3 would be 3 and x, and we look for what's common to each. We have a 3 common here and an x common here. And so my GCF of that first row, you can see, is 3x. So I pull out a 3x. Then I do the same thing with the second column, or second row here. The GCF of 2x and 2, pretty easy to see, I think, is 2. That is the greatest common factor between 2x and 2. Then we do the same thing with the first column. We find the GCF between 3x squared and 2x. And if you look at the two numbers, 3 and 2, the only thing they have in common is 1. But if you notice, we have an x squared on the top left, and on the bottom left we have an x, and so we have a common factor of x in each one. Now you can expect that these trinomials of the form ax squared plus bx plus c will factor in a similar fashion as the ones we did previously, the simple quadratics. So we're going to have a set of parentheses here, and there will be variables combined with numbers in here in each one. We're going to have 2 sets of parentheses. We're about to get the other factor here. So right here, in the second column, the greatest common factor of 3x and 2. Well, between the 3 and the 2, the greatest common factor is 1. That's the biggest number that divides into each without a remainder. the 2 does not have a variable attached, so x is not a common factor here. So the GCF for this second column here, right here, is just simply 1. Now notice that I didn't put any sign with these, but if you look at each of these are the factored answers for that original trinomial. One of them is x plus 1, the other one is 3x plus 2. Just to check that, if I use FOIL, multiply the first terms, x times 3x is 3x squared, x times 2, the outer term is 2x, 1 times 3x, that's what I'm doing next, is 3x, that's the inner term, and then 1 times 2, that's the last term too. So by using FOIL, we can see that we get the original trinomial, 3x squared plus 5x plus 2. So this is using the big X to find the factors, rewriting it, and then using the box to finish off with the factors on a trinomial of the form ax squared plus bx plus c, as you see up here at the top. So when a is not equal to 1, this is one of the methods we can use to factor this. It's a very visual method, the x with the box. We're going to practice that on a couple more. Some of you may be able to do this without using the x in the box. You might be able to figure out the factors just by guessing and checking and using multiplication. But in terms of a visual representation of what we're doing, it's hard to beat the big X with the box. So start like this. We're going to take first and the last term, multiply them together. That's 10. That goes in the top of the X. The middle term, 11, goes in the bottom. We need to find factors of 10. So we have 1 times 10, 2 times 5, that's it. Looking for the factors that add to equal 11. So we've got 1 times 10 this time. 1 times 10 multiplied to equal 10, but add to equal 11. So I'm going to put a 1 and a 10 here. All right. So move this over. Move that down just a little bit more. All right. So we're going to go ahead and draw our box next and rewrite that trinomial as 4 terms, inserting the terms in the correct place on the box. According to step 4 in the process on the previous page, we place the first term, 5x squared, here. Remember, we're just rewriting 5x squared plus 11x plus 2, but we're splitting 11x into 2 terms. Boom and boom. They are 10x and 1x. So we're taking that 11x and splitting it into 10x and 1x. So 5x squared in the top left, the 2 goes in the bottom right, the 10x and the 1x in any order go on the other 2 squares. Then I take and find the GCF of each row and each column. GCF of the first row is 5x. The GCF of the second row is another one kind of like the previous one. Its greatest common factor between 1 and 2 is just 1. Then let's go ahead and find the greatest common factor of the first column, going up and down here. We have a 5x squared and a 1x. GCF is x. Second column, the 10x and 2, the GCF is 2. It's the biggest number that divides into each of those without any remainder. So my factors are 5x plus 1 and x plus 2. All right, the one next to it, 7m squared plus 9m plus 2, is pretty similar to this one. I'm going to leave that for you to try with the Xbox method. And we're going to do one more here. We're going to go ahead and do the 4k squared plus 7k minus 15 in the bottom right using this method. Got more factors to consider on this one. So make my big X. We've got 15, negative 15, and 4. Negative 15 times 4 give me negative 60. Negative 60 has a lot of factors. There's a lot of possibilities here. So let me take a little bit of work to find the correct one. 17 goes in the bottom. And next, I'm going to consider all the factor pairs of negative 60. Now, because this is a negative 60, we're going to have one positive, one negative. Now, if I go through and list all of them, I'd start at 1 and 60 maybe, or negative 1 and 60. Obviously, those don't add up to equal 17. You can see that I'm going to have to work towards the middle before I find the correct combo, but we need a method for listing all the factors. So here we go. 2 and negative 30, we got negative 2 and positive 30. That difference is 28, so that's not going to work. 3 and 20, negative 3 and 20, 3 and negative 20. Oh, wait a minute, I think I've got it. So looking here at the negative 320, we don't really need to go any farther. We could keep going, list 4 and 15, and 5 and 12, and 6 and 10, and keep going. But it looks like negative 3 and 20 will work. So let's go ahead and stop there. A negative 3 here, a 20 here. So that's the x part of this factoring method. Draw our rectangular box. We're going to label this 4k squared in the top left, negative 15 in the bottom right. 20x and negative 3x will take the place of our, oh, it's not an x, it's a k, the place of our 17k. So we'll redo that. 20k and so we got 20k and what was it, negative 3k. And then we're going to find the greatest common factor of each row and each column. So, greatest common factor of the first row between 4k squared and 20k. Biggest number that goes into each of those is 4, and we have a k in each one. Bottom one, we've got a negative sign in here, negative 3k and a negative 15. If there's a negative in the edge here, we like to plot the negative right there, so this would be a negative 3. I'll show you why when we go to check it. First column, 4k squared and negative 3k has a common factor of k. And the second column, between 20k and negative 15, has a GCF of 5. Now let's just double check here because we had negatives to deal with. 4k times k is 4k squared. 4k times 5 is 20k. Negative 3 times k does give me negative 3k, so it checks out. Negative 3 times positive 5 is negative 15, so it checks out. So way to kind of check what you've done is to just keep it in that rectangular box form, multiply out your factors, make sure they all come out with the correct signs. So my final answer, factors are 4k minus 3 and k plus 5. And you are done. So I'll leave the other two for you to try for practice.